Section 7-8, Work Problems. In this section, we need to be able to solve work problems. I know, really creative. There is an important formula that you need to know for these problems, and it's going to be that work rate times time equals the amount of work done. Let's look at exactly what work rate is. Work rate is a ratio that deals with the amount of work done over the time it takes to get it done. So if Allie can paint a room in 4 hours, we consider her work rate to be that she can paint one room in 4 hours, the ratio 1 to 4. To put a label on it, we're talking about 1/4 room per hour. What the task is over the time it takes to complete it. Jake can read a comic book in 30 minutes. He can read one book in 30 minutes. Book per minute. But let's say I wanted this not per minute but per hour, because I was comparing it to another quantity that was per hour. How do I convert minutes into hours? Well, I could say that Jake can read a book in not 30 minutes, but a half hour. So then his work rate is 1/1/2 books, book per hour. But this is not a really nice way to write that. If I have a fraction within a fraction, just like when we were converting percents into fractions, I'm going to multiply the top and bottom by this denominator. So the top is going to be multiplied by 2, and the bottom is going to be multiplied by 2. So I could consider his work rate 1 book per 30 minutes, 1/30th, or 2 books per 1 hour. A hose can fill a pool in 3 days. That means the hose can fill 1 pool in 3 days. And the label would be pools per day. If you notice, the work rate is really the reciprocal of the time it takes to complete. Franklin can do a job in 6 hours, and Mike can do it in 4 hours. What part can they do working together for 2 hours? For y hours? So what we're going to do first is figure out the answer to this problem for 2 hours. Now whatever we do to 2 to solve this problem, we're going to eventually do to y and come up with some expression at the end. But let's handle it for 2. Remember that this formula that we want to use for this section is that work rate times time equals work done. So I'm going to figure out the work done by Franklin first. So F for Franklin. Franklin's work rate is 1 job for every 6 hours. The time that he is working is 2 hours. So that means the work that Franklin has done is 2/6 or 1/3. Same thing goes for Mike. Mike's work rate is 1 job in 4 hours. He is working for 2 hours, so that means the work that he gets done is 2 out of 4 or 1/2. Now because they're working together, I can add the work that Frank got done plus the work that Mike got done. 1/3 plus 2/3, if I get common denominators, this will be 2/6, 3/6, so my answer is 5/6. Working together for 2 hours, they will have 5/6 of the work done. Now we have the same problem again, but we want to figure it out for y hours. So what changes in everything that we just did? Well, instead of 2 and all of the answers that we got for 2, I'm going to use y instead. So Franklin has a work rate of 1/6 and he works for y number of hours. That makes the work that he gets done y/6. Mike has a work rate of 1/4 and he works for y hours. So the work that he gets done is y/4. Because they're working together, I can add the 2 to figure out the total work done. I need common denominators in order to add these 2 together, so my common denominator will be 12. That means I'm going to have 2y/12 for Franklin, and I will have 3y/12 for Mike. 2y plus 3y is 5y/12 will be the total work done. Yes, ladies and gentlemen, we are back to using charts in this problem. The nice thing about these charts, the columns will always be the same. Work rate times time equals work done. So let's see about filling out this chart. Abby has a work rate that she can mow one lawn in 2 hours. So her rate is one lawn in 2 hours. Carla uses an older lawnmower, so she has a work rate of one lawn per 3 hours. The question is asking us for how long will it take them to work. So time, we don't know. But they're working at the same time on the same lawn. So it's x for both of these. To figure out work done, we multiply across the table. 1/2 times x is x over 2. 1/3 times x is x over 3. Now we can set up a formula. I know that the work done by Abby plus the work done by Carla needs to add up to be one job done. This one represents the one lawn that they're trying to mow. Now I have an equation, now I can go through and solve it. We solve these types of equations in 7-3. I'm going to do that by multiplying everything by the LCD, which is 6. So this times 6, this times 6, this times 6. These cross cancel and I'm left with 3. These cross cancel and I'm left with 2, and I can do 1 times 6. So I have 3x plus 2x equals 6. 5x equals 6. X is 6 over 5. So that means time it takes, and in this case we're talking about time hours, it takes 6/5 or 1 1/5 hour for both girls. In this problem, Phil's work rate is 1 job per 12 hours. Rick's work rate is 1 job for 10 hours. What's tricky about this one is the time. They're both working together for 3 hours. But Phil is going to stop at some point and only work the 3 hours. Rick's going to keep working. We don't know how long he's going to keep working, so we call it X. Phil's only going to work 3 hours. Rick's going to work 3 hours plus whatever else is needed to finish the job. Multiply across to figure out the work that each of them does. Phil's going to do 1/4 of the job. Rick, because we don't know how much more of the job he needs to do, is going to do x plus 3 over 10. So this is the work that both of them have done. Because they're working together, I'm going to add these two up to get the one job that's done. To solve this equation, I'm going to multiply everything through by 40. So I get 10 plus, and here I'm going to cross cancel and get 4 left over. X plus 3 equals 40. Now I know you guys are very capable of finishing this problem. At the end, you should get that x is 4.5. That means Rick has to work 4.5 more hours to finish. I know that Chuck can shovel off the entire driveway in 40 minutes, so I know Chuck's work rate. The trick with this problem, though, is I don't know Joan's work rate. It doesn't say how long it takes her to do the driveway all by herself. So that's the x that I'm going to solve, and I'm going to solve it as 1 over x. X would be the amount of time Joan can do it alone. I do know that Chuck worked for 20 minutes, and then Joan joined him for another 10 before they finished the driveway. That means Chuck worked for 30 minutes. Joan only worked for 10. Multiply across to get the work done. And I will have these two fractions now. Add them up to equal the one job that is done. To solve this equation, I multiply by the LCD, and in this case that's 4x times 4x. So this cancels and I'm left 3x. The x's will cancel here. I'm left with 40, and over here I'm left with x. You guys can solve this equation now, and you get that x is 40. That means that Joan shovels the driveway herself
in 4 minutes.